Looking at this next graph here, this graph is showing that as we go in time, the amount of money given to schools looks like it's increasing. So this is the amount of money given to schools, and it certainly looks like there is an increasing trend here. In fact, when we look at trends, the steeper the trend, the greater the rate. Okay, so in this case here, it looks like it's a reasonable rate of growth. Okay, it looks like the amount of money increasing is reasonable. But if we take a look at the scale on the y-axis, well, the scale is only showing that it's gained maybe $1,000 over 3-year time here. So in the end, that's probably not that much, considering how much money is involved here. 68,000 or 69,000. So it's misleading that we've scaled the y-axis. Okay, so we scaled the y-axis. And it's to accentuate the differences again. Okay, so we're trying to show that looks like it's a greater difference than maybe there really is. So it looks like the graph is probably trying to show that the funding for schools is increasing. Okay, so this trend certainly is the case. And again, if we looked at this from a regular scale, the trend would look much flatter, which then is less convincing that the schools are getting more money. So again, we want to look at these scales. So when we take a look at this next one, okay, this one looks like the Y scale is pretty reasonable, and it looks like the amount of miles on a car is increasing kind of at a regular rate. But if you take a little bit closer look at the x-axis, we can notice there's something strange about the x-axis here. If you take a look at that difference there, that's 5-year difference. But if you look at the next spacing, which is the same horizontal spacing, but this only represents 2 years. And again, the same horizontal spacing here represents 3 years. So there's an inconsistent spacing on the x-axis. So what's actually happening is, well, it looks like there is quite a few miles on the first 5 years, but after that, it actually, because of the spacing here, the amount of miles is increasing differently than what maybe it's suggesting when we compare the slopes here and here. Okay, so in this case here, the slope, the scale on the x-axis is inconsistent. Okay, and if we actually made the scale on the x-axis the same, you would probably see, in fact, a little bit steeper slope that's involved in here. Okay, so what's the number of miles on a car is misleading? Well, it looks like maybe it's trying to show that it's kind of tailing off a little bit here, but really, if we kind of did the proper scale, okay, it's kind of going at pretty much a steady rate. All right, so it's probably trying to show that the miles on the car is decreasing. So it's decreasing over time. But really, that's probably not necessarily true. Okay, so this next one here, this is scores on the y-axis, and then the people are on the x-axis. And wow, you look at this information, you say, well, by just looking at it, it looks like Lazaro is clearly well, quite a bit better than the other players here. But if we take a little bit closer look at the scaling here, again, the y-axis scaling doesn't start till 100. So that means again we're by having this type of scaling, we're accentuating the differences between the scores. But the reality is there's not much difference between Craig, which is 103, and Lazaro, which is 109. There's only a score of difference of 6 over 100 scores. So again, this is misleading. Okay, so the y-axis scale is accentuating or amplifying the differences, whereas the differences really aren't that significant. Okay? So who do you think might have made this graph? Well, we could maybe think that Lazaro did because, he certainly looks much better than everyone else based on the scaling. On a regular, if we were scaled from 0, we'd see that most of these players are actually fairly even. Okay, whereas, it looks like Kim Lee, wow, he's way worse than Lazaro, who looks like 10 times better, but that's not really the case when you look at the bigger picture of the graph.